Lesson 9.4 is about angles of circles. The first theorem is that when you have two chords that intersect inside of a circle, anywhere inside of the circle, the measure of the angle formed by intersecting chords is equal to half the sum of the arcs. So in this little diagram, the measure of angle 1 is equal to 1/2 of the sum of arc A and arc B. The second theorem is this, and it goes for whenever you have either two secants, two tangents, or a secant and a tangent that are that intersect a circle from some external point outside of a circle. You have the external angle that's captured, in this example angle 1, is equal to half the difference of the intersected arcs. So in this first diagram, I have two secants, and they are drawn through the circle from this exterior point right here. And the way I find the measure of angle 1 is that angle 1 is equal to 1/2 the difference between the two intersected arcs. So the difference between the bigger arc minus the smaller arc between A and B. And that's how I'd find the measure of that external angle 1. The same thing goes for when you have two tangents drawn to a circle from an external point. The measure of the angle that's captured inside of those two tangents, that external angle, is equal to half the difference of the intersected arcs. And in this case, when you've got two tangents, notice that those two intersected arcs account for the entire 360 degrees of the angle. So in this case, the measure of angle 2 is half the difference between intercepted arc A and intercepted arc B. And lastly, when we have from a point that's external to a circle, when we have a secant and a tangent drawn from that point to the circle, that angle, that little external angle, in this case angle 3, is also equal to half the difference between the intercepted arcs. So measure of angle 3 in this diagram is equal to half the measure of arc A minus arc B. Okay, now for some examples. So in this first example, I have a circle with two chords intersecting in the middle of it, and I want to find the measure of angle 1. So angle 1 will be equal to half the sum of the intersected arcs. So remember, when we have the intersection of chords, we're dealing with half the sum of the 40-degree arc plus the 30-degree arc. So that's half of 70 degrees, or 35 degrees. All right, in this next example, I have two secants drawn through a circle from an external point. So to find the measure of angle 2 is going to be half the difference between the intersected arcs. So half of 120 minus 40 degrees, or 1/2 of 80 degrees, or 40 degrees. Okay, the next example, I have two tangents drawn to a circle from a point outside the circle, and that angle 3, that external angle, should be equal to the difference between the two intersected arcs, half the difference, between the two intersected arcs. Notice that both of those intersected arcs, when I add them together, it's the full 360, because these lines are tangent. The points are tangency points are the only thing that divide the two intersected arcs. So measure 3 is equal to half 260 minus 100 degrees. So that's half of 160 degrees, or 80 degrees. Okay, in the next little example, I have a secant and a tangent drawn to the circle from an external point, And that angle, that external angle there, is 45 degrees. So I have to find the measure of arc x there, x degrees. So I can set up an equation to do this. I know that the 45-degree angle has to be half of the difference between the two intersected arc measures. So half of 170 degrees minus x degrees. Now to solve for x, I want to isolate it. So first I need to isolate the 170 minus x. So I'll multiply both sides by 2 to clear the fraction. So 90 degrees equals 170 minus x. So x will be equal to 80 degrees. Okay, in the next example, I have two chords intersecting inside of a circle. I have an angle that's a 75-degree angle formed at that intersection, and I know that that 75 degrees should be equal to half the sum of the intersected arcs, one of which is x that I have to solve for. So 75 is half of the 100-degree arc plus the arc that measures x degrees. So multiplying both sides by 2, I get 150 is 100 plus x. So x is 50 degrees. Okay, in this last example, we're going to solve for the arc measure of x. Again, I have a secant and a tangent drawn to a circle from an external point. So I know that that 30-degree angle has to equal half of the difference between the intercepted arcs. So half of x minus 70 degrees. And so, clearing the fraction here, I'll get 60 equals x minus 70 degrees. So I can see that x is equal to 130 degrees. And that's it for angles of circles.